Hey guys, this is Professor Janacek, and I want to go over a few concepts regarding integration. Let's begin with the antiderivative. Uppercase f of x is called the antiderivative of lowercase f of x if the derivative of uppercase f of x is equal to lowercase f of x. The indefinite integral is the most general form of the antiderivative, and it's denoted as the integral of f of x dx, which is equal to uppercase f of x plus c, where c is a constant. We have the integral symbol. F of x in this case is called the integrand, and that dx is the differential. X is our variable of integration, and c is our constant of integration. Now, the definite integral going from a to b is denoted as the integral from a to b of f of x dx, and that is equal to the limit as n goes to infinity of the sum from k goes from 1 to n of f of x sub k star delta x. And this is for f being continuous on the interval from a to b, which is divided into n subintervals. Each subinterval is of width delta x, and this this x sub k star is in the kth subinterval. A couple things to note about this: the delta x's could actually be different widths for each subinterval, and we could select this x sub k star in a different manner for each one of those. Typically, however, we'll select subintervals of equal width, and it's really nice to use the midpoint for the x value. Now, this interval from a to b is referred to as the interval of integration. A is the lower limit of integration, and b is the upper limit of integration. And the Riemann sum is actually this summation here, and there are a few ways of writing that Riemann sum. I've chosen to use the notation where we're taking the limit going from n to as n approaches infinity. But like I said, there are different ways of writing this Riemann sum and the limit of this Riemann sum. So a quick little review: the antiderivative is kind of undoing the derivative, trying to find the function that if we take its derivative, we get what we started from. The indefinite integral is a general antiderivative, and it has this form. And the definite integral is over an interval, and it has this form. We do have a few properties here. First off, if I integrate from a to b, I can turn that around and integrate from b to a as long as I take the opposite sign of that result. If I integrate just from a to a, we end up with 0. If I integrate a constant times a function, I can factor that constant out, and that's exactly what's going on here. This is a summation. In fact, that is why the integral sign looks like a stretched out S. It is the limit of a sum, and so we could factor a constant out of that summation. And if we integrate, we have the integral of the sum or difference of two functions. That's the same thing as the sum or difference of the integral of the two functions. And also, if we're integrating from a to b, we could actually break that apart and go from a to c and then from c to b and add those two integrals together. So there are just a few little properties and definitions involving integrals. Enjoy!